if k is your 0, x minus k is your factor. K is your 0, and this whole linear expression is your factor. So when you plug k into x, k minus k becomes 0. That's why it's 0. Let me reiterate. So when you plug 2 into here, 2 minus 2 is 0. 0 times quotient is 0. That's why it's called 0, okay?
Yeah.
Okay, let's go back. So x minus 2 is your first factor. So this is gone. How about this one?
X minus 1 over 3.
X minus 1 over 3. So x plus 1 over 3, right?
Yeah.
Yeah. Okay, now I'm not done yet. Maybe we can put them also answered. Any? What would you do to make factors out of this clue?
X plus 1 plus or minus, yeah. I think don't need the minus sign anymore, right?
Yeah, you can just leave it like that. That's good. Yeah, because you just, calculated in your head already, right?
Mm-hmm.
Yeah, so it's going to be, what's the second one?
X minus 1 minus square root of...
Minus
1? Plus 1.
Plus 1 and then minus square root of 5, right? Okay, very good. Before we expand, what do we do? Same logic. All cubic polynomials here. Find all QWERTY polynomials. I'm not satisfied because we have different cases like 4x minus 8. This can be also an answer vector, right? We have 2x minus 4. This can be also another factor. There's so many variations. So in the same way, we just multiply some variable here because we don't know. Okay, so you just found the QWERTY. So when you expand, because there are x, 4 x's leading all factors, so eventually you're going to have a form like x fourth power and plus bx. I don't know what ABC at the moment because I didn't expand yet. So you're going to have this kind of form. Okay? Again, so reiterate the relationship between 0 and the factor. You just observe your factors individually. Okay? And then you should be able to tell what's your zeros. So again, this example 4 gives you zeros first and then ask you to construct polynomials. But sometimes you have to see the polynomials and then tell me the zeros right away. So if you plug what number to make the entire thing 0? If you have x is 2 or p2, everything is a 0, right? If you plug negative 1 over 3, then everything is a 0. So 0, p minus 1 minus square root of 5 is 0. So you have 4 different numbers that satisfies this polynomial become 0. Okay? So if we're clear with this, let's work on the 5th example. So you have to find k, that x minus 2 is a factor of x cubed plus k, some unknown number k, x squared minus 3x plus 6. Hence, fully factorize this polynomial. So my first clue is this is the factor. As soon as you see this is a factor, you have to make a connection that P2 is going to be 0. Okay? So this is given as Px, for instance, and then if you plug 2, let's see what happens. 2 cubed plus k times 2 squared minus 3 times 2 plus a 6. Okay, except for k part, we should know all of this. So it's 8 minus 6 plus 6 plus 4k. So it's gone right here. So only thing left over is 8 plus 4k, which is 0. What is your k? Minus 2. Now, what you can say is that, okay, px is now complete. X cubed plus, minus 2k, minus 2x squared minus 3x plus 6 is your complete px. Very good. We know that x minus 2 is one of the factors, and then it's going to be some kind of quadratic equation qx. So if we want to completely factorize this px, we have discussed the long division, right? So x cubed minus 2x squared minus 3x plus 6 is divided by x minus 2 because this is a factor. And then you should have no remainder because it's a factor. X squared, you multiply x squared for both term, and then boom, 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 boom. And then you have 3 minus 3x plus 6 just carried over. So you are going to multiply negative 3 there. So negative 3x plus 6. It's very clean. No remainder as we expected. So what you can say is x minus 2 times x squared minus 3. You can finish here, or because they ask you to completely fully factorize it, you can take one more step, x minus 2, and then x plus square root of 3, x minus square root of 3. Then you're complete. So your possible zeros are 2 or plus minus square root of 3. You are done.